So in this segment, let us take up some more problems on simultaneous linear equations. These are the word problems. Let's look at this one. The sum of two numbers is 97. So that's my first statement. So let me assume the numbers are x and y. So I will say let the numbers be x and y. It is given that the sum is 97. That means x plus y is equal to 97. This is my first equation, right? Now let's look at the second condition which is given. If the larger number is divided by the smaller, the quotient is 7. So in this, let us assume that x is the larger number. So what they're telling me is when I divide the larger number by the smaller number, the quotient is 7 and the remainder is 1. So we are well aware of the relation that dividend is equal to divisor multiplied by quotient plus the remainder, right? So the dividend in this case is x. So x is equal to, the divisor is 7, right? So let us mark the different terms in this. Y is called the divisor, the one who divides. X is the dividend, the one who gets divided. 7 is the quotient and 1 is my remainder, right? So now therefore I can write x is equal to divisor, that's y, into quotient, that is 7, plus the remainder. And therefore my second equation is x equals 7y plus 1, right? So this is now my second equation. So what I can now do is I can substitute the value of x in my first equation. So substitute x equals 7y plus 1 in the first equation, and we will get x is 7y plus 1. So 7y plus 1 plus y is equal to 97, which means 8y is equal to 96, transposing 1 to the other side, which means y is equal to 12. And therefore one of the numbers is 12. I can now substitute y as 12. So substitute y equal to 12, say in the first equation, and we get x plus 12 is equal to 97, which basically means x is equal to 97 minus 12, which is 85. And therefore the way I would write the solution is the two numbers are 85 and 12, right? These are the two numbers. And let's quickly check if our assumption is right, or rather if our answer is right. 85 and 12 indeed add up to 97. So this condition is satisfied. And if I divide 85 by 12, let's see what happens. So I know that 12 sevens are 84 and the remainder is 1. So the quotient is indeed 7 and the remainder is 1. Therefore this also satisfies the given condition. And therefore the answer 85 and 12 actually matches both the given conditions. Hence our solution is correct. So let me pause for a few seconds and then I will move on to the next question. Okay, moving on to the next question. A man starts with a certain monthly salary and a fixed increment every year. If his salary after 2 years is 11,000 and after 4 years it is 14,000, find his starting salary. So this is one variable, and the annual increment. So annual increment means that increment which he receives every year. So I will say let the starting salary, let his starting salary be X, let the starting salary be X, and let the annual increment be equal to Y. Okay. So now let's see, after 2 years his salary is 11,000. So let us see what needs to be done with this. So his salary after 2 years basically will be the starting salary. So the starting salary is X, and in 2 years he is going to receive increment 2 times, right? So every year he receives an increment of Y. So in 2 years he will receive an increment of 2Y. So this would be X plus 2Y is equal to 11,000. So let me elaborate. What is happening is his initial salary is X, and then he's getting an increment of Y every year, right? So after 2 years, this is the first year, this is the end of the first year, and this is the end of the second year. After 2 years, if you notice, his salary will be X plus, he has received 2 increments, so it is X plus 2Y. And after 4 years, let's see what happens. So this is after the third year, and then this is after the fourth year. So after 4 years, he would have received 4 Y increments, and therefore his salary after 4 years will be X plus 4Y. So the first equation is X plus 2Y equals 11,000, because it is mentioned that after 2 years his salary is 11,000. And after 4 years his salary is 14,000. So the second equation that I can frame is X plus 4Y is equal to 14,000. So now that these two equations have been constructed, right, this is the first equation and this is the second equation. Now I can easily eliminate X. So let's decide to eliminate X. Let us subtract the two equations. So on subtracting the two equations, you will notice that 2y minus 4y becomes minus 2y, and 11,000 minus 14,000 becomes minus 3,000, which means y is minus 3,000 divided by minus 2, which is equal to 1,500. This means his annual increment is y, which is basically rupees 1,500. Now let us substitute y as 1,500. So substitute y as 1,500 in, say, the first equation. So we get x plus 2 times 1,500 is equal to 11,000, which means x plus 3,000 is equal to 11,000, and therefore the value of x is 8,000. So this means his fixed salary is rupees 8,000. His fixed salary is rupees 8,000, and his annual increment is rupees 1,500, right? So this is how I can solve this particular question. The important point here was figuring out the exact cycle. So a diagram is always helpful in mathematics, where I was able to draw this diagram and I was able to make out his salary after 2 years and after 4 years. So let me pause again for a couple of seconds and then we move on to the next one. Okay, let's continue with the next one. Okay, consider this question. In a right angle triangle, one of the acute angles. So let us first draw a right angle triangle. So in a right angle triangle, it is given that one of the acute angles. So we know that there are two acute angles in this right angle triangle. Let's label it. So I have ABC. So let me say, let triangle ABC be right angle triangle, be a right angle triangle at vertex B. This means angle B is equal to 90 degree, and let the other two angles. So I have to find the measure of both the acute angles. So let angle A be equal to X and angle C equal to Y. So I have one of the acute angles is X. So let this angle be X and let this particular angle be Y. So now let's see what conditions they have given. One of the acute angle exceeds the other by 20 degrees, right? So one of the acute angle exceeds the other by 20 degrees. So let's figure this out now. Now one of the acute angle exceeds the other by 20 means the difference between them has to be 20 degrees. So I would say X minus Y is equal to 20, right? This is my first equation. The acute angle X is greater than the acute angle Y by 20 degrees. So this is the first equation that I've got. Now I need to find the second equation. I know that these are all angles of a triangle. So I can say X plus Y plus 90 degree is equal to 180 degree. And this is because of angle sum property of a triangle. Right, this is the reason, angle sum property of a triangle. So therefore I can say X plus Y is now equal to 180 minus 90, which means X plus Y is equal to 90. So this is my second equation now. X plus Y equal to 90 is my second equation. So now what I can do is I can solve for X and Y simultaneously. Naturally here adding the two equations will help me get rid of Y. So let's add the two equations. I have X minus Y equal to 20 and X plus Y equal to 90. So let me add these two equations. I get 2X equal to 110, which means X is 55. And now let me substitute X as 55. So substitute X as 55 in the second equation, and what I will get is 55 plus Y is equal to 90, which implies Y equals 35, and therefore the two acute angles are 55 degrees and 35 degrees, right? So this is how we solve for the acute angles in this question. We used two properties. One was the angle sum property of a triangle, and the other was the condition given in the question, which was one acute angle exceeding the other by 20 degrees. So pausing for a few seconds. Okay, let us continue. The perimeter of an isosceles triangle is 24 centimeters. If the length of the congruent sides is 13 centimeter less than twice the base, find the lengths of all sides. So in this question, we have an isosceles triangle. So let's quickly label the vertices. So here let the vertices be A, B and C. So I have A, B and C. Let the equal sides be x. So these two sides are x, and let the base be y. Base is basically the unequal side, right? So let me mention what my variables are. Let the equal sides of the isosceles triangle. Let the equal sides of the isosceles triangle be x centimeters, and let the base, which is basically the unequal side, let the base be y centimeter, right? So now let's see what condition is given. The perimeter is 24 centimeters. So let's frame the equation. Perimeter is nothing but the sum of all sides. So x plus y is equal to 24, which means the first equation is 2x plus y is equal to 24. This is the first equation, right? Now let's consider the second equation. It's given that the length of the congruent side, so the length of the congruent side is 13 centimeter less than twice the base. So the length of the congruent side is basically x. X is 13 less than twice the base. So what is the meaning of twice the base? Twice the base is 2y. So x is 13 less than 2y. That means if I subtract 13 from 2y, 13 less than 2y means 2y minus 13, and x is actually equal to that, right? So I get x is equal to 2y minus 13. X is 13 less than twice the base. So this is my second equation now. And now I can go ahead and I can substitute x in terms of y. So let's substitute x equals 2y minus 13 in the first equation. So what we get is 2 times 2y minus 13. So I have substituted x as 2y minus 13 here. So 2 times 2y minus 13 plus y is equal to 24. So now let us solve the given equation for y. So now I will say 2 times 2y is 4y. 2 times negative 13 is negative 26 plus y is equal to 24. 4y plus y is 5y minus 26 is equal to 24, which means 5y is equal to 24 plus 26, which means 5y is equal to 50, and therefore y is equal to 50 by 5, which is 10. So the value of y is 10. Now we can substitute y equal to 10. We can substitute y equal to 10 in, say, the first equation. So we get 2x plus 10 is equal to 24, which means x is equal to 7. So if you solve this equation, you will get the value of x as 7. So therefore the equal sides are 7 centimeters each. So this is 7 and this is 7, and the base y is equal to 10 centimeters. Let's check if the solution matches the given requirements. Look at the perimeter. 7 plus 7, 14. 14 plus 10 is 24. So the perimeter is indeed 24, which was what was given in the question, right? So perimeter is 24, and the length of the congruent side, that is 7, is 13 centimeters less than twice the base. So what is the base? The base is 10. Twice the base would be 20, and 13 less than that would be 20 minus 13, which is 7, and that matches the equal length of the equal side that I have. So therefore the solution that we have exactly matches the given requirements, and hence our answer is correct. Pausing. Okay, moving on to the next one. The sum of two numbers is 60. That's one condition given. If the greater number is 8 more than thrice the smaller number, find the numbers. So again, I can assign some variables to these unknown quantities. I would say let the greater number be x. Let the greater number be x and the smaller number be y. Smaller number be y. So now let's see what we have. The sum of these two numbers is 60. So x plus y is going to be equal to 60. This is my first condition. Okay, this is the first condition. And now let's consider the greater number is 8 more than thrice the smaller number. So the greater number, let me write it down. Greater number is 8 more than thrice, that is 3 times the smaller number, right? That means the greater number, that is x, is 8 more than 3 times the smaller number, which is y, right? Which means the second equation is x equals 8 plus 3y. This is my second equation. So now what I'm going to do is I have to solve for x and y. So I will say substitute. Substitute x as 8 plus 3y in the first equation. So what I get is 8 plus 3y. So I have substituted the value of x. So 8 plus 3y plus y is equal to 60, which means 8 plus 4y. So this means 8 plus 4y is equal to 60, or 4y is equal to 52, which implies y is equal to 13. Therefore, the value of y is 13. And now let's substitute. Let us substitute y as 13 in, say, you can do it in either of the two equations. In the first equation, x plus 13 is equal to 60, which implies x is equal to 60 minus 13, and therefore x is equal to 47. So I can say the two numbers are 47 and 13. Now let's check if our solution is right. The sum of the two numbers is 60, so that exactly matches what is given. And the greater number, that is 47, is 8 more than thrice the smaller number. So the smaller number here is 13. Thrice of 13 is 39, and 8 more than 39 is 47. So it exactly matches our answer, right? So 3 times 13 is 39, and 8 more than 39 is 47, which matches the first number. Therefore, the answer is the two numbers are 47 and 13. We also check that our solution matches the conditions that are given. Pausing. Okay, moving on to the next one. A two-digit number is 4 times the sum of its digits. If 8 is added to the number, the digits are reversed. So a two-digit number is 4 times the sum of its digits. So let's see how to go about this particular question. Let the two digits be x and y, right? So I would start off saying that let the two-digit number be xy. So x is in the tens place and y is in the units place. A two-digit number is 4 times the sum of its digits. That means this number that you have xy is 4 times the sum of its digits, right? So it is x plus y. So let's write the equation now. I know that xy, when I write the number two-digit number as xy, its actual value is 10x plus y is equal to 4x plus 4y. That means 10x minus 4x is equal to 4y minus y, which means 10x minus 4x is 6x is equal to 3y, and therefore I can say that 2x is equal to y. So the first equation that I have is y equals 2x. Okay. Now let's look at the second condition. I think there's a correction required in this question. It should be if 18 is added. Okay, so let's make that correction. So if 18 is added to the number, the digits are reversed. So let's see what needs to be done now. If I add 18 to this number, that is in this xy number, if I add 18, then the digits are getting reversed. That is, the number becomes yx. Okay. So let's see how I should frame this particular equation, or how should I expand it now. Xy basically can be written as 10x plus y plus 18 is equal to yx can be written as 10y plus x. So let's shift 10x and y to the other side. I get 18 is equal to 10y plus x minus 10x minus y, which means 18 is equal to 10y minus y is 9y and x minus 10x is minus 9x, which means I can divide everything by 2. So I get 2 is equal to y minus x. This is my second equation, right? So I have two equations now. Y equals 2x, that's the first equation. And y minus x is equal to 2, that's my second equation. So now I can solve these two equations simultaneously. I will substitute the value of y as 2x as I found in the first equation. I will substitute this value in the second equation. So I get 2 equals 2x minus x, which implies x is indeed equal to 2 and y is twice of x, that is 4, and therefore the number that I obtained, so the two-digit number, therefore the two-digit number is x is at the tens place, so it is 20, and 4 is at the units place, so the number is 24. Now let's see if this satisfies all our conditions. This 24 is 4 times the sum of the digits, that is 4 plus 2 is 6 and 6 times 4 is 24, so it satisfies the first condition. And if I add 18 to 24, so when I add 18 to 24, I get 42, which means that the digits are indeed getting reversed. So 24 is indeed 4 times 2 plus 4. That is the first condition that was given. And when I add 18 to the number, the digits get reversed. That is the second condition. Therefore, the two-digit number is 24, and this solution satisfies both our requirements. I am pausing for a couple of seconds. Okay, let's continue. The sum of two numbers is 1000. So it's given that sum of two numbers is 1000. And the difference between their squares, is 256,000, right? Find the numbers. So of course my variables will have to be the two numbers. So let's assign the variables. I will say let the two numbers be x and y. It is given that their sum is 1000, which means x plus y is given as 1000. This is my first condition, right? So this is the first condition that I have. It's also given that the difference between their squares, that is x square minus y square, this is the difference is when I subtract between their squares, is equal to 256,000, right? That's my second equation. Now I have to think of how to get the values of x and y from these two equations. The first equation is definitely a linear equation, but I notice that my second equation is a quadratic equation now, where the power of the variables is 2. So I'm going to think of solving this question. What comes to my mind is, first I can write x square minus y square. So the strategy 1 would be, I am going to write x square minus y square as x plus y multiplied by x minus y, which equals 256,000. So it's given that x plus y is 1000. So 1000 multiplied by x minus y is equal to 256,000, which means x minus y is equal to 256. So this is a linear equation now. So what I can do is, I have cancelled the zeros on both sides, right? 256,000 by 1000 gives me 256, right? Or if I were to write it and show it to you, let me write it again. Okay, so let me rewrite it. So I have 1000 into x minus y. Let me write that part also again. So x plus y is 1000 according to the first equation. So 1000 multiplied by x minus y is 256,000, which means x minus y would be 256,000 divided by 1000. And now the three zeros cancel, so I get 256, which means my third equation is x minus y is equal to 256. Right? This is my third equation. So therefore, what I can now do is, I can take up equations 1 and 3 and solve for x and y. So I have x plus y is equal to 1000 and x minus y is equal to 256. So if I add these two equations, I get 2x is equal to 1256, which means x is equal to 628. And then if I substitute x as 628, so substitute x as 628, I get y is equal to 1000 minus 628, which is equal to 372. So this is how I can solve for the numbers x and y. Therefore, the two numbers are 628 and 372. Let's check if it satisfies both the conditions. If I were to find 628 plus 372, it would be 1000. And you can always find the squares of 628 and 372. And if you find the difference, you will get 256,000. Yeah, basically 256,000. So this is how we can calculate for the values of x and y. Another method to solve this would have been to substitute x as 1000 minus y and then substitute x as 1000 minus y in the second equation. So I'll pause for a few seconds and then I will use the second strategy also to solve this question. Okay, let us use another strategy to solve this question. It is using the concept of substitution. So what I'm going to do is, from the first equation, I can say that x is equal to 1000 minus y, right? I'm going to make this substitution. So let us substitute x as 1000 minus y in the equation 2, right? So when I make that substitution, let's see what I get. Instead of x, I have to substitute 1000 minus y. So 1000 minus y the whole square minus y square is equal to 256,000. Now this bracket is of the form a minus b the whole square. So let us expand it. A minus b the whole square is a square minus 2 into 1000 into y plus b square, that is y square, minus y square is equal to 256,000. Now plus y square minus y square cancels, which means 1 followed by 6 zeros, right? That is equal to 10 lakh minus 2000 y is equal to 256000, which means negative 2000 y is equal to 256,000 minus 10 lakh. And now I can divide everything by 1000 because 1000 is common everywhere. So I get negative 2y is equal to 256 minus 1000, and therefore negative 2y is equal to 256 minus 1000 is minus 744. And therefore y is equal to negative 744 by negative 2, which is 372. So if y is equal to 372, now I can find the value of x. So substitute y is equal to, substitute y as 372 in say the first equation, you will get x equals 628. So in both cases the answers exactly matched. In the first method, I used a square minus b square is a plus b into a minus b to find the value of a minus b, and I used that those two equations to solve for x and y. Whereas in this case, I have made the substitution, and using a minus b the whole square, I was able to solve this particular question. So I am pausing for a couple of minutes for you to take a look at it, and then we will continue. Okay, let's continue now. Let us take a look at this question. In a factory, the ratio of skilled and unskilled workers, the ratio of the salary of skilled and unskilled workers is 5:3. Okay, so there are two types of workers in this factory. One is the skilled workers and the other is the unskilled workers. And the ratio of their salary is 5:3. So I'm going to assign the variables immediately, because if you look at the question, it says find daily wages of the skilled and unskilled workers. So I will say let the daily wage of the skilled worker be X, and let the daily wage of the unskilled worker be Y, right? So now it is given that the ratio of their salaries of the skilled to unskilled. So basically skilled is the first letter that is mentioned, or the first quantity that is mentioned, right? So skilled is the first quantity and unskilled is the second quantity. Therefore, the ratio is going to be the wage of the skilled worker to that of the unskilled worker is given as 5 upon 3. So I can immediately cross multiply. So 3x, therefore, so when I say I'm going to cross multiply, it means I'm going to multiply 3 with the numerator of the opposite side, right? So that will become 3x, and y with the numerator of the opposite side, which is 5. So 3x therefore becomes equal to 5y, and therefore 3x minus 5y is equal to 0. This is my first equation. Okay, so now I'm going to frame the second equation. This is where I frame my first equation and I let it be. Let us fill this with a color so that we mark it as our first equation. Now it's given that total salary of one day of both of them. So the total salary of both of them, that is, we have to add their two salaries. So the total salary will be x plus y. That total salary will be x plus y, which is equal to 720. That's my second equation, right? So these are the two equations that I now have, and I have to solve for them. So I can easily use the elimination method. Let me decide to eliminate y. So if I want to eliminate y, what I'm going to do is, let me write the first equation as it is. So 3x minus 5y is equal to 0. And this is the first equation. And let me take the second equation and multiply it by 5. So I get 5x plus 5y is equal to 725 are 3600. So now if I were to add these two equations, I get minus 5y plus 5y cancels. So 8x is equal to 3600, which means x is equal to 3600 divided by 8, and therefore x is equal to 450. Therefore, the value of x is 450. Now using this value of 450, I should be able to calculate y. So I will say substitute x as 450, substitute x as 450 in, say, the second equation, yeah, and I get x x is 450. So 450 plus y is going to be 720, which means y is equal to 720 minus 450. 720 minus 450 is 270, and therefore the value of x is 450 and y is 720. So in the statement I can say the daily wages of the skilled and unskilled workers are rupees 450 and rupees 270 respectively, right? So this is how I can solve this particular question. Again, let me pause for a couple of minutes and then we will continue with the next one. Okay, moving on to the next question. Okay, let us read this question. Kantabai bought 1.5 kg tea and 5 kg sugar from a shop. She paid rupees 50 as the return fare for rickshaw. The total expense was 700. Okay, so let me first note down something that's very important. The total expense was 700, of which she paid 50 rupees for the return fare, which means 1.5 kg tea, right? That is what she bought. 1.5 kg tea and 5 kg sugar. 5 kg sugar actually costs not 700 but 700 minus 50, because out of 750 rupees was paid for the return fare. Therefore, this will cost rupees 650. This is my first equation. Let's read on. Then she realized that by ordering online, the goods can be bought with free home delivery at the same price. So next month, so now she is not going to travel, so there is no fare that she is going to pay. She placed online order for 2 kg tea and 7 kg sugar, and she paid 880 rupees for that. So she had 2 kg tea and 7 kg sugar. Okay, and for this she paid rupees 880, right? So this is my second equation. I'm just going to pause for a few seconds so that you can take a look at the question and the equations, and then we will solve this one. Okay, so now we need to assign the variables. Find the rate of sugar and tea per kg. So let's assign some variables. Let the rate of sugar be rupees S, okay, per kg, and the rate of tea be rupees T per kg. Okay, so 1.5 kg tea. So 1.5, let me convert it into a mixed fraction. Sorry, this is already a mixed fraction. Let me convert it into an improper fraction. So 1.5 is 3 by 2. So 3 by 2 times T plus 5 kg sugar. Each kg costs S rupees. So 5 kg will cost 5S is equal to 650. And 2 kg tea, that's 2T plus 7 kg sugar, that's 7S, will cost 880. So now what I'm going to do is, I don't like this denominator, the denominator of 2. So let me simply multiply the whole equation by 2. So multiplying this whole equation by 2 gives me 3t by 2 into 2 gives me 3t plus 5s multiplied by 2 gives me 10s is equal to 652s are 1300. So now what I can do is I can consider these as my actual variables. So I have 3t plus 10s is equal to 1300 and 2t plus 7s is equal to 880. I decide to eliminate t. So let this be equation 3 and let this be equation 4. So let's eliminate t. So let's multiply the third equation by 2. So you get 6t plus 20s is equal to 1300 into 2 is 2600. And let's multiply fourth equation by 3. So you get 6t plus 21s is equal to 883s are 2640, right? And now let's subtract. So when I subtract, let's see what happens. 60 minus 60 cancels. 20s minus 21s is minus s equals 2600 minus 2640 is minus 40, which means that s is equal to 40. So the price of sugar per kg is 40 rupees. Now let us substitute. Let us substitute s as 40 in, say, equation 3. Okay. So 3t plus 10 times 40, s is 40, is equal to 1300, which means 3t plus 400 is equal to 1300, and that means 3t is equal to 900, which implies t is equal to 300. And therefore, in the statement form, I can say that my answer is, so I can say that the price of sugar is 40 rupees per kg and the price of tea is 300 rupees per kg. Now let's do a quick check if our solution is right. 1.5 kg of tea is at 300 rupees per kg. So 1.5 kg would cost you 450 rupees. And 5 kg of sugar, each kg costs 40 rupees. So 5 kg will cost 200. So 450 plus 200 is indeed 650. Each kg of tea is costing 300. So 2 kg will cost 600. And 7 kg of sugar, each kg is 40 rupees. So 7 kg will cost 280. So 600 plus 280 is equal to 880. So it seems like our solution satisfies both the equations and both the conditions, and therefore our answer has to be right. So I'll pause for a few seconds and we are done with the questions in this particular segment.